Hello, friends. This is Ahmed again with another question. This question, which was submitted, it's a constraint optimization problem. So it's a constraint optimization. So, and the question is a max min function if x and y is equal to 2x squared minus 3y squared, and it's a subject to two constraints. And the first constraint is x plus 2y equal 10. And then the second constraint is 2x minus y equal to 15. So we have a optimization problem for a function of 2x to the power of 2 minus 3y to the power of 2, or you can see 2x squared, 3y squared, and then this function is subject to two constraints. One is x plus 2y equal 10, and 2x minus y is equal 15. So before I solve this problem, we're going to go in details solving this problem. So we need to talk about the concept of constraint optimization. What geometric condition enable us to optimize a function if that function is f x and y, which is f is equal to f of x and y, and it's subject to a constraint. So this is subject to subject to constraint. Given the constraint is given by g of x and y and so on. This constraint could be x, y, z, any number you can think of, and that is equal to c. So where c is a constant, this is a constant. So how can we exploit this geometric condition to find the extreme value of the function, the extreme value of this function subject to this constraint? So I know that many professors at the university level, whether it's being at the fourth year economics or at the master level economics, they consider or they teach how to find the extreme value of function of both unrestricted domains and on closed bounded domains. Other types of optimization problem involves maximizing or minimizing, like the one that we have, a quantity subject to an external constraint. So in these cases, the extreme value frequently won't occur at the point where the gradient is zero, but rather at other points that satisfies an important geometric condition. So these problems are often called constraint optimization problem and can be solved with a method called a Lagrangian multiplier. So the method that we're going to be using to solve this problem, it's called Lagrangian. Lagrange. So it's Lagrange multiplier. So again, Lagrange multiplier is taught in fourth year undergraduate and also at the master level in economics at universities in microeconomics around the globe, particularly United States and Canada. I'm not too sure about Europe. However, now the Lagrangian multiplier technique lets you and me to find the maximum or minimum of a multivariable function. This multivariable function, I mean that we have a function of f, x, y, z, etc., etc., etc. And where there is some constraint on the input values me and you are allowed to use. So let's go to the next page. This technique only applies to constraint that looks something like this. So constraint like G, X, Y, Z, etc., and that is equal to C. Here in this problem, G is another multivariable function with the same input space as F. And C is some constant. If you use an example, if the input space is two-dimensional, the graph of F function, which is the linear which is the line representing G, X, and Y is equal to C, is projected onto it and might look something like this. So, and forgive my drawing, this is something I'm not really expert on, but this is our X and this is our Y. And we have something like here that is F, X, and Y. So we have, let's say, something like this. And then we have something going down, and that is like, let's say it's another something like this. So this is a line that is going up, 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 and then it's coming down, and it's going like this. So this the way it looks, because you can't see it, and then you see this line is going straight, and then it's going up, 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 up here, and then it becomes a maximum, then it's going down. So it's something like this that we have like this. So it's most likely like this one. It's going straight up and down. So the goal here is to find the highest point. The goal is to find the highest point on this line. And the core idea is to look for a point where the contour lines of F and G are tangent to each other. And this is the same as finding points where the gradient vector of F and G are parallel to each other. So the entire process can be boiled down into setting the gradient of a certain function called the Lagrangian equal to a zero vector. And we're going to do the example how we set Lagrangian and how we solve by just the questions that it was giving to me. So the problem was max. Again, I'm going to write it even though I write it in the first page, but I'm just going to repeat it here. So f in x and y, and that is equal to 2x squared minus 3y squared, and it's a subject to two constraints, and the first constraint is x plus 2y equal 10, and the second constraint is 2x minus y equal to 15. Now, so for this one, as I said, we need to use Lagrangian multiplier, and Lagrangian multiplier. So we need, from what we can see, so this is our main function, and we have 1 and 2 constraint. So we need lambda 1 and we need lambda 2. So these are our multiplier. So in math or in economics, this is the symbol for Lagrangian. And then you can set the Lagrangian in the following way. Lagrangian, the way you do it is the function and the objective function, which is 2x squared minus 3y squared plus lambda 1, which is the multiplier. And we rearrange this to make it look like we get 10, take x and 2y on the other side of equality. And when we move x from here to other side of equality, then the sign will change. So that becomes minus x. And also this becomes minus 2y. Then plus we have the second constraint, and that is 2. We do the same thing. We do 15, move to x on the other side. The sign here is positive, moving it on the other side of equality. It becomes negative, and then minus y, moving it on the other side, becomes plus y. So now we have the objective function, and we have 2 constraint, and that's multiplied by the Lagrange multiplier, which is lambda 1 and lambda 2. It could be more than that, could be lambda 3, lambda 4, and lambda 5. Once you set this one, then you're set to go, and then now it's easy as long as you know how to take a derivative of a function like this. So you can take a function, a derivative of this Lagrangian with respect to x, start from first one. So if you're looking at this function, there's no multiplication or anything. This is by itself and 3y is by itself. So therefore, if you take the derivative of this one, 2x squared minus 3y squared, then that becomes 4x. Derivative of this function with respect to x becomes 0 because there is no x. And also looking at here, we only see x here. So, and then the derivative of minus x becomes minus 1, and that becomes minus 1 times, because it's multiplied by lambda, and becomes minus 1. And then we have here x. So the derivative of minus 2x becomes minus 2, and multiplied by lambda becomes minus 2 lambda, and that is equal to 0. And then it's always easier to label your equation as 1, 2, and 3, and 4. Now, we take the derivative of this Lagrangian multiplier with respect to y. And again, there is no y here, so the derivative of this with respect to y is 0. Then we have to take the derivative of this because we can see only y here. 2 times 3 becomes minus 6. That's y. And now we see y here. So the derivative of minus 2y is minus 2 multiplied by lambda. That becomes minus 2 lambda 1. So I forgot here to put lambda 2. It's very important. And right here is positive. The derivative of plus y is 1, and it's multiplied by lambda becomes plus lambda 2, and that is equal to 0. And that's our equation number 2. For equation, we have the derivative of Lagrangian with respect to lambda 1. So here we have a function which is lambda 1 times this one. So this is like lambda 1 times this. I know I can tell you that the derivative of this function of lambda 1 times 10 minus 1 becomes this one. Probably some of you will get it, some of you don't, but I'm just going to go ahead and write it, that the derivative of this Lagrangian with respect to lambda 1, it becomes 10 minus x minus 2y equal to 0, and that is equation number 3. So this is how it's done. We have lambda 1, and then it's times 10 minus x minus 2y. So this is a multiplication. The way we take the derivative is this is a first, and this is a second. The way we take the derivative, we take the derivative of first times the second plus first times the derivative of second. So if we take the derivative of lambda 1 is 1 times Then the second term, which is 10 minus x minus 2y, plus the first one, which is lambda 1, times the derivative of this second term with respect to lambda. There is no lambda, so that becomes 0. So 0 times lambda 1, this whole terms become 0. So what we are left is 1 times 10 minus x minus 2y. And this is how we have this one. And now for, again, we can take the derivative of lambda with respect to lambda 2 and Lagrangian with respect to lambda 2. Again, as I showed you before, that becomes 15, which is the constraint that we have equal to 0, and that's equation number 4. Now, it's just rearranging some of these equations, and let's see. From equation 3, let's rearrange equation 3. And then we write equation 3 as x is equal to 10 minus 2y. So let's write this as an equation number 5 because it makes it more easy. Now you sub equation 5 into equation 4. So equation 5, 4, we have 15 minus 2x, and then instead of x, we substitute x is equal to 10 minus 2y. 10 minus 2y. And then we have the term which is y, that is equal to 0. So we have 15 minus 20 plus 4y plus y is equal to 0. It's minus 5 plus 5y is equal to 0. 5 is equal to 5y, and y is equal to 5 over 5. Therefore, y is equal to 1. So now we solve for y is equal to 1. So now it's even easier because now we know y is equal to 1. You can simply sub y is equal to 1 into equation number 5. And y is equal to 1, and then you're solving for x. So we have the equation x is equal to 10 minus 2y. 2 for y, we have 1. Therefore, it's 10 minus 2. And therefore, x is equal to 8. So we have y is equal to 1, x is equal to 8. And then now we take x is equal to 8, and then you sub it into equation 1. So we substitute x is equal to 8, and then into equation number 1. We have 4x, 4 times 8, and then we have minus lambda 1, minus 2 lambda 2, and that is equal to 0. So we have 4 times 8 is 32, and minus lambda 1, minus 2 lambda 2, and that is equal to 0. So this becomes our equation number 6. And then we sub y is equal to 1 into equation number 2. So we had minus 6y, y is equal to 1, and then minus 2 lambda 1 plus lambda 2, that's equal to 0. So it's minus 6 minus 2 lambda 1 plus lambda 2 is equal to 0. That's become equation number 7. So from equation 6, we have 32 minus lambda 1 and minus 2 lambda 2. That's equal to 0. So we rearrange and then solve for lambda 1. So lambda 1 is equal to 32. Bring this one on the other side of equality, lambda 1 becomes positive. Then 32 minus 2 lambda 2 is equal to 0. So now this becomes our equation number 8. And then now we sub 8 into equation number 7. So we have minus 6 and minus 2. And then lambda 1. So for lambda 1, we substitute 32 minus 2 lambda 2, that is equal to 0. And we solve minus 6 and then minus 64. 2 times 32 is 64. And also minus 2 times minus 2 lambda, that becomes plus 4 lambda 2. Actually, you know what? Here we forgot another term, which is lambda 2 is equal to 0. Plus lambda 2 is equal to 0. Say if we haven't noticed this one, then we would have forgot. So that's minus 70 and plus 4 lambda 2 and lambda 2, that becomes 5. Lambda 2 is equal to 0. So we have 70 equals to 5. Lambda 2 and lambda 2 is equal. 70 divided by 5, that's equal to 14. So lambda 2 is equal to 14. So now it's even better. We have lambda 2 is equal to 2. Now sub lambda 2 is equal to 14 into equation 8 to solve for lambda 1. Solve for lambda 1. Therefore, lambda 1 is equal to 32 minus 2 times 14. Lambda 1 is equal to 32 minus 28. And lambda 1 is equal to 32 minus 28. That becomes 4. So now, in conclusion, because I don't have B per C for this question, it's just only this one. So you can write that X is equal 8, Y is equal 1, lambda 1 is equal 4, lambda 2 is equal 14, is a valid candidate. So that's the end of the question. I hope you liked it, and I hope that's going to help you. And if you haven't subscribed to the channel, please do so. And if you can, please share this video. Again, thank you, and see you again.